So before we move into grade 12 material, there's a certain amount of grade 11 stuff that you absolutely need to have down pat. If you don't have any of this, then you basically can't do advanced functions. If you are missing anything here, you're going to have a hard time. So the second you see something here that confuses you, or that you look at and say, maybe I don't remember that so well, you need to tell me, and we're going to work through that. Just make sure that it's all solid, and that way we can go through without any trouble. So really the prerequisites that you learn in grade 12 and grade 11 are split into the basics and things about functions. So as we move into higher level math, we're more interested about functions instead of just adding numbers together, raising things to exponents, taking logarithms, doing sine and cosine. We actually want to explore functions, their properties, and what kind of things functions can tell us and how they can be applied to the real world. So the main basics that you need to take away from grade 11 are the exponent and radical laws. Okay, and what do these look like? Just a quick refresh. We have a to the b, which means literally you multiply a b times. Okay, and from here we can get a couple of properties. For example, a to the b to the c is equal to a to the bc. A to the b times a to the c is equal to a to the b plus c. And the last one is a to the b divided by a to the c is equal to the a b minus c. Okay? If this is at all unfamiliar, you really need to let me know, and we need to go over this very quickly, because this is going to become like sort of second nature by the time this course is over. Similarly, we have radical laws. So you can take a root of a number, the bth root of a number, and all that means, so whenever I write the symbol, this means the same thing as. So what this symbol means is the exact same thing as a raised to the bth power is x raised to the bth power is equal to a. So for example, you have the cube root of 8 is equal to 2. That's the same thing as 2 cubed is equal to 8. Okay. From here, you can get some other nice properties as well. So for example, and this is just an example, I'm not going to go through all of them. These should have been covered in your curriculum. If you have root a times root b, this is the exact same thing as root ab. Simple stuff like that. Root a over root b, that's the same thing as root a over b. So some simple properties like that you should be really familiar with. These exponent and radical laws, they're not going to be immediately useful at the beginning of the course, but they're going to become very important as we start and towards the middle of the course. The second basic thing that you really need to be familiar with is factoring. At this point in time, there are probably only 3 main factoring rules that you need to remember. And I'm not counting like the basic factoring. Like you should know, for example, that b plus ac is equal to a times b plus c. I'm talking about the more advanced factoring. So in grade 10, you learn this factoring trick for quadratics. So you learn how to factor a quadratic. One example of this is, for example, I can take x squared plus 5x plus 6, and you should be able to do some work and find out that this is equal to x plus 2 times x plus 3. To double check that, you take these two numbers, you add them together, it makes 5. But if you multiply them together, it makes 6. So simple things like that you should be able to do really quickly. This actually is going to become super useful right at the beginning of the course. So make sure you have that down pat. After quadratic factoring, you notice that sometimes you get expressions that look like x squared minus a squared. And you do a bit of work and you find out that you can decompose this as x plus a times x minus a. This is super important and very easy to miss. In fact, many of the errors that come from the first chapter of this course will be because of this, difference of squares. And what's really frustrating about this, and math in general, is that oftentimes you can know exactly what this means. If I ask you what is x squared minus a squared, you will tell me it is x plus a times x minus a. But if I give you a question and I hide it in the middle of a bunch of words, and then somewhere down the line you have to do a difference of squares without me telling you anything, you might miss it. And that's what's really difficult about math, is because you've got to be really careful and attentive to these kinds of things, which can pop up literally anywhere. The third really big factoring thing, that would be the forms x plus or minus a squared. Again, this one is a really easy thing to miss, and it's really frustrating because people will either mess this up completely or they'll forget to do it in the first place. What I mean by mess it up completely is that oftentimes you'll see people do this. X minus a squared is equal to x plus a times x minus a. In other words, they think that this is the exact same thing as that. It is not. Now, I could go ahead and justify to you why it's not, but this is something that you should have learned in your grade 11 curriculum. This is something that you should look at, and it should strain your soul looking at this. This is bad. Very, very bad. So, of course, the correct formulas, and if you don't remember these, you should be able to derive them by yourself. It's not very difficult. X squared minus 2xa plus a squared, and x squared plus 2xa plus a squared. Okay? These two formulas should be really familiar to you. And if they're not by now, make sure they are as soon as possible. This and this together will cause you a lot of grief if you're not very familiar with it within the first chapter. Literally all of the first chapter of this course is making sure you're really comfortable with this, and then maybe extending it a little bit here and there. Instead of just using squares, we're going to be using cubes. So it's going to be a little more sophisticated, a little more difficult, and it'll throw in one more thing that you have to remember. So kind of annoying. Now, in grade 11, the math course is called Functions. That suggests that you learned about things called functions. And indeed, there are 3 types of functions in the curriculum that should have been made absolutely clear to you. And you're going to look at this and say, well, there's something wrong there, because I'm going to say linear and quadratic in the same thing. And you're going to be like, no, those are two completely different things. Linear functions look like mx plus b, and quadratic functions look like ax squared plus bx plus c. How do those look anything similar? These are completely different things. Well, you're right, except that there is one way in which they are similar. And actually, the way in which they are similar is the first main subject of advanced functions. These two are actually examples of what we call polynomial functions. Don't need to know that right now, but you should be 100% clear on how to do anything regarding quadratic functions and anything regarding linear functions. This includes graphing, knowing how to find the function from the graph, and for quadratics you might want to be able to factor or solve for x, things like that. So this is like really, really important. Things that you might have learned in grade 12 include solving a system of equations where you have a quadratic and a line at the same time, and you just want to find out like what the points of intersection are. That's one very common thing to do in grade 11, and that's going to be a pretty useful skill. Just to have that graphical intuition that, you know, if I'm solving this quadratic, it might be like x squared minus 9, or let's do plus x squared plus 1. And this line might be, for example, let's say 1/2 x plus 3. Being able to solve this system of equations is really important. And it's going to become very helpful. So the next thing that you would have done is exponential functions. Exponential functions, they have a very unique characteristic, which is that as you go closer and closer to negative infinity, the function approaches 0. And it kind of always does this kind of swoosh thing and just goes off to infinity. Notice that if I look at that point there, this is the point 0, 1. This is reflective of the fact that for any real number, so for all numbers, x to the 0 is 1. Okay? And the reason why is something that you should have learned in your previous courses. If you don't know the exact reason why, that's not super important. It's not terribly vital to understanding how this function works. It's just something that it would help you gain a better intuition for these functions, because we're going to be exploring these in a lot more depth, and we're actually going to do something really crazy towards the end of the course, which is do something called an inverse function. It's a way of basically reversing exponentiation, and what I mean by that will become clearer as we go through the course. In fact, inverting functions is something that we're going to be looking at somewhat early on in the course. You need a good intuition for what it means for a function to have an inverse, and like, what does that even mean, invert a function? But exponential functions are things that you should have covered in grade 11, and you should at least know that they look like this and cross the y-axis at the point 0, 1 all the time. The last main topic is your trig. Now, trig is sort of, in high school, one of those big bad things that no one ever wants to touch, because there are two very big complicated words that come out of it, which are sine and cosine. I need to sneeze. Okay, so the main things here, there's a lot of them. That's why it's such a problem. Because it looks like you're doing two completely random things at the same time, and you're just giving them the same name, sine and cosine. So for example, in grade 11, in grade 10 actually, you should have known, using some basic trig, that if I have a triangle, a right triangle, with some angle theta, and I call this like A, B, and C, right? You can get that sine of theta is equal to opposite over hypotenuse, which is B over C. Cosine is equal to adjacent over hypotenuse, so it's A over C. And you would have probably learned that tan is sine over cosine, and in this case that means B over C divided by A over C, and that's the same thing as B over A, which corresponds exactly to the TOA, opposite over adjacent. This should be super familiar by now, no problems here. But there is one catch, which is what happens if your triangle isn't right? You've got like some random triangle with some random angles, One of the big things in grade 11 is to learn how to solve triangles. Now, to do this, we have two tools, which is the sine law and the cosine law. These are very confusing names. The only reason why anyone might remember this is because the sine law kind of like has a lot of sines in it. And the cosine law has a cosine in it. Cosine C is equal to A squared plus B squared minus 2AB. No, this is totally wrong. See, even I have trouble remembering this thing. Okay, yeah, so you got these two. Now, the really great thing about grade 12 is that you're almost never going to do this. So these two things, you learn them in grade 11, great, but you probably don't need to really use them until you hit vectors and calculus. So keep that at the back of your mind, but take comfort in knowing that you don't have to do any of this, at least for the time being. The really confusing thing is when people start talking about the unit circle, and then they show you the sine graph, which looks something like this. And they show you the cosine graph, which looks something like that. Okay? And then they point at the unit circle and say, look, it's the same thing. That's really confusing. Unfortunately, this is often the way trig is taught. And you can have good intentions, but at the end of the day, this causes a lot of problems. The reason why is because what really is going on in this circle? So maybe I can give like a 2-minute crash course. Basically, this is the unit circle. Unit circle meaning that it has a radius of 1, right? So this is the point 1, 0. Okay. And what you can do is take a triangle that has a point anywhere on the unit circle, and then just draw lines that connect it to the x-axis. Okay? Then what you have is that because this is a circle, every point around the circle is distance 1 away from the origin. Okay? And then we can do the sine and cosine thing. Here, notice that c, in both cases, is always going to be 1. So what does that mean? Let's say you have an x component here and a y component here, right? And this point then has coordinates x, y. Fine. But what is sine of this angle? That's what we want to know. This is why we use the unit circle. We want to know what sine of this angle theta is. Well, because of this law here, b over c, you literally look at the same picture down here and see that's y divided by 1. But that's just y, so we know that sine of theta is equal to y. Similarly, you could do the same thing with cosine and find out that cosine of theta is equal to x. If any of that is confusing, you should pause the video right now, try and work through it yourself, and you should be getting this. This is something that's pretty critical. So the next thing that we want to do with trig is import this idea called radians. Now this one is a little weird because I know people who have not done radians in grade 11, and I know people who did way too much radians in grade 11. So depending on your familiarity with this, the trig section might go a little more difficult if you have less experience with radians. Basically, the moral of the story is we're going to switch from degrees to radians, and what that's going to involve is you completely forgetting anything you know about degrees. If you start thinking in radians, you are thinking correctly. Degrees are just some magical unit of notation that some guy came up with, and it's not very practical. It's not very intuitive. But this is the true angle of measurement. If you don't believe me, you will believe me in about 3-4 weeks time. Okay, that's about all the main material I want to cover from grade 11. There's just one last big idea that is going to underlie pretty much everything in advanced functions. And depending on how much you understand this concept right now, advanced functions as a course is going to either be really, really easy or just mildly interesting. The reason why is because you've probably seen this before. Sometimes it's 1 over b, but I just put b. You've probably seen this. And you may have known, using the quadratic or the exponential, or maybe even the trig, the trig versions of this thing, is that this thing causes horizontal movement. This thing causes vertical movement. And sometimes people like to call these stretching. I like to call them scaling. Scaling makes a lot more sense. So this one covers vertical scaling. And this one covers horizontal scaling. maybe you've only heard a little bit about this, maybe you've only played around with it a little bit with quadratics. So for example, in the quadratic case, this is what happens when you get it into a form that looks like a times x minus c squared plus d, and the b is like usually not even there. So for example, you might have 5x plus 1 minus 3 squared. And then you should be able to tell me, like, okay, so this thing will move the quadratic up, down 3. This will move it to the left by 1 unit. This will stretch everything by a factor of 5. So those are kinds of things that you should be able to read off just from doing that. You may have had some exposure with this idea in exponential, and you probably had some exposure to this in the trig case, but you're going to get super familiar with this, and by the end of the course, this is basically like the answer to every question. If you understand this perfectly, then every question's answer is pretty much just dumped in front of you. If you don't understand it perfectly right now, that's not a problem. We're going to do so many examples of it that eventually it will enter your brain through osmosis. So that is about all that I want to cover for today. Ready. So again, if any of that I just said did not make any sense at all, then we're going to have a problem, and you need to tell me right away so that we can fix that problem. If it all made sense, then great. You are totally ready for this course. You might even have a little bit of an advantage if absolutely everything I said made complete sense. Right now, what I want to do, though, is just give you an overview of what we're doing in this course and why you're taking this course in the first place. So this course is called Advanced Functions. Okay? And it has this course code. I guess I should write it. Okay. Why are you taking this course? This is probably like a really bad question to ask because I already know the answer. But if you understand why you are taking this course, that will help to motivate you to complete things better and dictate how much time you should spend working on this course. Not now, in the fall term. Because this is often a prerequisite for many universities. Even if you don't like math, they force you to take it because they're going to look at it anyways. So this is probably going to enter your core course list that you submit to your university application. So that makes this one pretty high priority. What is it about? Well, it says in the name Advanced Functions. At least that's what the ministry thought. To me, that doesn't actually mean anything. And it certainly doesn't represent what this course is about. Yes, the functions that you're going to be looking at in this course are more sophisticated, but they are by no means really advanced. You sort of start to get the idea of what advanced means when you look at calculus, because calculus gives you a way of telling mathematically how advanced a function is. With that being said, there are a few key things that you want to take away from this course, and if you don't take these away, then you basically come out of this course with nothing, and you're going to enter calc and vectors with a lot of difficulty. So, just like your regular functions course, there is a basics section, but this basics section is covered in essentially 1.5 weeks. We are going to cover it in a couple of days. It's very important that you pay attention to this basic section, because the ideas that are going to be presented here are going to carry out throughout the rest of the course. And it's these basic things that are probably going to make the difference between a 90 and an 80 in your final grade. Now, this course primarily focuses on the function stuff. So the main branches of functions that we're going to be covering, I'll give you them all right now. Polynomial, a word that you may or may not have heard before, but you're going to hear it a whole ton in advanced functions. Trigonometric. So yeah, you probably work with sine, cosine, tan, but we're going to work with also the inverse of sine, the inverse of cosine, the inverse of tan, secant, cosecant, cotan. None of those might actually make any sense to you right now, but that's a brief overview of everything that you're going to be doing in trig. The whole point of this is to really, really, really understand sine, cosine, and tan, because at the university level, it's this that gets people. This is probably the most difficult part of the entire course, because there's so much content, and just getting all the relations right in your head is a difficult thing in and of itself. The next thing is the exponentials. But here we also have something called logarithmic. So you've probably seen the log button on your calculator and tried pressing it, putting in some numbers, and figured out that it did absolutely nothing you cared about. So you kind of like disregarded it and it became a thing, you know, in the air. Connected to this is the function ln, and connected to this is the function e to the x. Both of these should be buttons on your calculator, and we are going to explore how this is the father of all exponentials, and this is the mother of all logarithms. These two have an extremely close relationship with each other, and anything that you can say about logs, you can express it in terms of ln. Anything that you can say about exponentials, you can say it in terms of e. These two are probably going to be the most important things, the most important ideas that you take out of advanced functions. And they're going to be really important when you get to calc and vectors. I'm pretty sure that covers most. Oh, yeah. Okay, there's one last one. We are actually going to do this right after polynomials because it makes the most sense. But these are called rationals. You may have heard of them. You may have done a little bit of them in your grade 11 course. I don't know how much you did, because that actually varies from school to school. So let me just give you a quick rundown of how this course is going to go. We're going to start off with these basic stuff and then move on quickly to polynomials, rationals, trigonometry. Exponentials and logarithms are the last thing that we're going to be doing. It's very important that you pay attention in the trigonometry section, because that's probably the most difficult part of the entire course. It's going to take us the longest, maybe up to 2 weeks, to go through all the material. Underlying all of these, though, are a couple of ideas that we're going to mention sort of as we move into the calculus and vectors portion of the course. And these are piecewise functions and inverse functions. Both of these are more complex ideas which are not often taught in courses unless your teacher is very enthusiastic about the subject material. But they're really good ideas to have in mind because they help you as you go forward, and they're gonna, especially piecewise functions, are gonna come into really, really important focus as you move into MCV, which is the calculus course. So that's about all I wanted to do today. Please let me know how the video and audio quality turned out, and hopefully we can, this is a workable setup for you.